Welcome back to Notes in Unit 2. We've talked about the structure of an atom and what isotopes are. Now we're going to determine how to find the average atomic mass of multiple different isotopes. So keep watching. Here we have two different isotopes of lithium. So we have lithium 6 and lithium 7. Remembering that those numbers after that name is the mass number. So this is a lithium atom with a mass of 6, a mass number of 6, and a lithium atom with a mass number of 7, meaning they have different numbers of neutrons. So the thing that is different between these is that the 6 one has 3 neutrons, while the 7 has 4. So then another thing that we can know about these different isotopes is their abundance in nature. So lithium 6 is only about 7.59% of the lithium on Earth, while lithium 7 is 92.41% of the lithium on Earth. So lithium can come in both of these forms, and the only difference between them is how many neutrons they have. So one of the things we notice on the periodic table is that each of these different elements has its atomic number, which comes from that number of protons. So we have the atomic number, which determines which element each of these is. And then we also have a mass number, which is actually the atomic mass. So it's different from the mass number that we see with our atoms because it is an average. So this is going to be the average mass of the different isotopes that this can come in. So let's see how we can do that calculations on our own with this lithium element. And it's two different isotopes. So here are those isotopes again in their abundances. And so what we're going to be doing is we're going to be doing a weighted average. We're going to be saying that 7.59% of that mass is going to be coming from that lithium 6, and then 92.41% of that mass is coming from the lithium 7. So let's do that calculation now. I have this fancy chart which makes it a little easier to see how we're going to do the math. But first we have the isotope name, then we'll be putting in the mass number, the abundance, and then we'll be able to do that weighted average, add those different parts together, and find that average atomic mass. So for lithium 6, our mass number is 6. And so this is the closest whole number to the actual atomic mass of that isotope. So we can just use this whole number and it will be close enough to the average atomic mass once we calculate it out. So we'll be using that mass number and then multiply it by that abundance. So if we take 6 and we multiply it by 7.59, we get 45.54. Because we multiply it by that full percentage, now we just have to divide by 100 to make sure that we get the actual fraction that it is supposed to be. So now 45.54 divided by 100 is going to give us 0.4554. Now let's see what that partial mass coming from lithium 7 will be. Once again, we're going to use that mass number, which we know from that isotope name, that it has a mass number of 7, and so the mass of this atom is very close to 7 AMUs. It has an abundance of 92.41%, so let's multiply those together. 7 times 92.41 gives us 646.87. Then to get the actual fraction, we divide by 100, giving us 6.4687. And now we add both of those up to get that full average atomic mass. And when I did that, I got 6.9241 AMUs for the average atomic mass of a lithium atom. So if you had a bunch of lithium, you didn't know what isotopes it was, you would assume that on average they have a mass close to 6.9241 AMUs. All Alright, so now it's your turn to try it on your own. Here we have carbon. So carbon-12 has an abundance of 98.93%. Carbon-13 has an abundance of 1.07%. And carbon-14 does exist. You can find it on Earth, but it's in such small quantities that it won't change the average atomic mass. It won't really contribute to those different abundances just because it's such a minute amount. Alright, so I'm going to let you pause this video, and then when we come back, I'll run through these really quickly just so you can see how I did it. So pause and try it on your own. Alright, here we go. Carbon-12 with a mass number of 12 and abundance of 98.93. When we multiply those, we get 1,187.16, and then divide that by 100, and we get 11.8716. Same with carbon-13. With a mass number of 13 and an abundance of 1.07%. Multiplying that, we get 13.91 divided by 100 goes down to 0.1391. So now these are our two partial masses, and then we just add them together, which gives us an average atomic mass of 12.0107 AMUs. So that's how you calculate the average atomic mass for an element and all of its isotopes that have abundances on Earth. So now try it on your own and see if you can do this without the chart. You're just going to multiply the mass number by the abundance, divide by 100, and add all those partial masses together to get that weighted average of that average atomic mass. Good luck, you've got this.